All right, good morning, guys. I have been here along with Georgie and Donnie from 8 o'clock. And I'm only seeing 5 of you here, with myself 6. And there are so many others to come. There are 7 more students who should be joining. But I think last week I ended up waiting half an hour, and I'm now looking at the clock and I'm seeing that it's almost half an hour. So what I'm going to do is just to wait another 5 minutes, but I'm going to see if I can post something. Please, please. I've got some past papers for you, and yesterday when I was doing the online registration, I remember to send out the past papers at that time, and I didn't. All right, let me project something on screen, and see what can happen in the meantime. I forgot to upload the paper, but I know that was the next thing for me to do. Silly me. All right. Let me do that and then send the past papers. I think that's where I want to start today. I know Elizabeth and Sachel and Tajay are joining us for the first time, so they may not be able to fully follow immediately. But as I said before, it's not a problem. Kind of sound like a broken record now, but we're actually waiting for the CXC results that came out yesterday so that we can have additional students in the class. I think online I have 11 of you already. So I'm not worried about whether or not this class will continue to grow. But I will still have to go over what it is that I did. I've completed Unit 1 already, but I'll still go over Unit 1 because other students are coming. So what I want to do is just to work some past papers today. Maybe not necessarily go through Unit 1 again because I sure come next week when we're having more students. Morning, you hear me?
Yes, sir.
Okay. Oh, DeAndre, right. Hey, DeAndre, how are you, Papa? So, yeah, welcome. So, I am going to be sharing something with you. And when I do that, I'm just going to work some questions. For those of you, Sachel and Elizabeth, don't be worried if you're not following. I will just go through the stuff with you because I still have to start over. When I say start over from scratch. But what I want to do is you students who are with me already, that come when the other students start, you are way ahead of the class. So now we have 2 different classes to teach because I'll have to move on with you for the other stuff and then try and catch up at some other point in time. So I am excited for what is to come. No, I don't want to read on the copy. Get off. I don't want to read on the copy. Oh man. All right, so this. Okay, good. All right, so I will share that. I'm going to just give you something to do. Copy. And I will post this in a group for those students who just joined us, so you don't have to worry. As I said before, I don't want anybody to be concerned about you just joining class and the session gone all the way. I mean, I get this stuff. Fret not. You are going to be fine. Let me just let I do know here. Oh crap. what I'm doing here is, for those of you who are new coming, I am giving you. So this is a question that we gave towards the end of the class last week, and I'm now giving you this one. I don't know if I write this one. Hold on, let me see if I can change this one here to something else. And then forgot what I had it for. All right, so I want you to use indices to work with the question. So I'm going to mute you, and then I'm going to see if I can send off the past papers in the group, because that's where I want to start today. And then we'll just work out way backwards. So start that. Those of you who are just joining, if you don't understand what to do, please, I'm going to beg you, don't be worried, don't be frustrated, don't get afraid. You will be perfectly fine. All right? Soon come. One word. Anyone has finished yet? Anybody finish it? Are you hearing me, guys? Hello? Is there anyone in the class hearing me? Can you just let me know, please?
Yes, sir.
Come on, students. I don't know. Anybody hearing me? Right. Let me mute, because I'm
Yes,
looking.
sir, we're hearing.
Is there anyone? Oh, so you hear me, Elizabeth, but nobody's answering. Okay, can you speak, Elizabeth, please? Because I'm not hearing anything from my device. And
Sir, what you said? Sir,
right, so I am having some connectivity issues now because I'm not hearing a word. Let me just check my that is in. Let me log on into another device because I don't know what is happening.
Recording in progress.
Are you hearing me now?
Yes,
Well,
sir. Hearing, sir.
Okay.
Sir, mute one of the mics.
Yeah, man, that's what I'm trying to do. All right. I don't know what happened a while ago. The system worked well for me for class, didn't I? Don't know why it wasn't giving me any juice at all just now. All right. So I was asking, and maybe you've answered me several times, but I just wasn't hearing. Anybody finish the question that I gave?
Yes, sir.
All right. What was your answer?
3 to the negative 3.
3 to the negative 3. Anybody else got that one? Talk to me. I need to hear it. Students, okay, so let me just set out something because I think the others already know. Is it an answer question? It's too early in the morning. If me not get no energy from uno, me go drop asleep. Real talk. So I asked a question. I don't know if I'm being heard. So I asked if anybody get it, and I heard Christian's voice saying yes, sir, 3 to the something. And I'm trying to get from the others if you are able to do it. Can you now please answer me? All right. This thing is not working out today at all.
Hear what you said?
I'm asking, were you able to do the question?
Yes, sir.
All right, thank you. What you got for your answer?
3 and 10, negative 10 over 3.
No. Okay. Who is this? Elizabeth?
Danny.
Danny. Danny, remember, you know, it says your final answer as an index. Your final answer is an index. So we expect you to use indices and not to work it as if you're doing a, what do you call it? A factorization question.
So you need to explain what they do.
I know, I'm just doing the question and then I'll do the explanation after.
Oh. We treat to the fourth.
You want me to put another line? Okay, I can put another line there. All right, so what it is that we're doing is I'm saying to you that.
So you can answer the question.
Sure, go ahead.
So the 3 to the negative 3 is incorrect.
3 to the negative 3 is not incorrect, but I don't know if you were here with us, Christian, when I said to you that we normally write our answer as a positive index.
Oh, the positive index.
Right.
So I know that thing, but I just never remember.
Yeah, man. So I wouldn't mark it wrong. The most I may do is maybe take off a mark, and it depends too. But we normally write our answer as a positive index. Always. All right, so let me just go through what it is that we did. So because we're using indices, it says evaluate writing your final answer as an index. We have to use indices in order to do the question. So I'm converting 9 as an index. Now 9 can only be converted as 3 squares, nothing else. So that's why this 9 will becomes 3 squares. And 1 over 3 is the same thing as 3 to the negative 1. 1 over 3 is the same thing as 3 to the negative 1. All right, so recall, 1 over a to the positive m is going to be equals to a to the negative m. 1 over a to the positive m is going to be equals to 1 over a to the negative m, rubbishness. 1 over a to the positive m is going to be equals to a to the negative m, right? So I'm converting, so it's positive in the denominator, so when it goes into the numerator, it becomes negative. All right, so I'm converting 1 over a to the positive m to a to the negative m. So this 1 over 3 now becomes 3 to the minus 1. And I'm going through this because I'm very aware that we have some students who have joined us for the first time. Normally, when I'm doing this question, I don't do the recall, but for the purposes of those who would have joined late, matter of fact, is Tajay here? No, Miss Allison,
and Miss Colonnette gonna just sneak up on the ice and don't even say, "Oh, they do, sir. Say, look at breakfast here." You don't understand me. All right. I'm missing Tajay. 7, 8, 9, 10, 11. There are 4 people. Oh, Tajay, Lorian, Kerry, and Kerry. Okay, all right. So I'm learning my students. All right. So now, when I convert this 1/3 as 1/8 to the 1/8 to the positive m to the a to the negative m, which gives me 3 to the minus 1, the law says when I'm multiplying and the bases are the same, I'm going to be adding my powers. When I'm multiplying and the bases are the same, I'm going to be adding my powers. Also is also when I'm multiplying and the bases are the same, I'm adding my powers. So the base is 3 and the base again is 3. My power is 2 and my power is -1. So when I'm multiplying and the bases are the same, I add my powers. So 2 plus -1 is going to be equals to +1. So this is how I get the +1 down here. I think I should put this right here. All right, and then now recall a to the positive n over a to the positive n. When I'm dividing, I'm going to be subtracting my powers. So it becomes 1 over 1 a to the, sorry, 3 to the 1 minus 4. Let me just put that there so that Christian, I know that he understands, but just to let him see what it is at the end. I'm going to paste that there. And then I'm going to write this as 3 to the, I'm going to write that as 3 to the 1 minus 4. 3 to the 1 minus 4. Which is going to be equals to 3 to the -3, which is what Christian got, equals 3 to the -3. And I'm going to put that in blue, and blue is really representing for me my partial answer, right? My final answer is in red, and blue is just a partial answer. So I'm reconverting 3 to the -3 using this law, using that law. All right, so what is really happening? I can use the laws many times over, so as to kind of look untidy this way. Let me just space them out so you can. Right, so you see, you can use one law many times in a question, like I did for the 1/8 to the -m. Let me just reverse it and show you that it can also be reversed too. So notice I've reversed it. A to the -m is now going to be equal to 1/8 to the +m. And that's what we got our final answer to be, 1/3 cubes. All right. Now, again, I'm fully aware that some of you joined. Let me ask the question now. And this question is really for the new people. And let me just check something here. New people. DeAndre shouldn't have a problem with that. But anyway, let me ask DeAndre and oh, Elizabeth gone? Elizabeth drop off. Oh dear. All right. Are there any questions? Sachelle, how you feel, honey?
Yes, sir. I understand.
Very good. DeAndre, how you feel, Pops?
Understand.
Nice. All right, so DeAndre is one of my sons here, guys, but him have no sense. So if you
That
hear
don't
him,
make no sense.
all right, DeAndre, let us not even start just yet. All right, good. So the book back. Georgie, how you feel?
Sir, I understand.
Very nice.
Oh, sir, or anyone, I would like to ask a question.
Go right ahead, Danny.
As it relates to paying for the course, it's the same way you pay for your school fee, right?
Paying for the course, meaning paying for the yeah. Oh, yeah.
It's true payments and then
Yes, man, and give them your
What did the
ID
lady
number.
say?
And then what they can do is, oh, she was asking DeAndre how it is that you go and pay for your course. No,
No, not she, the other lady.
Oh, I'm not sure, but let me answer. Donny. So Donny, you see, because we call it now pandemic, so your teacher love straight online. So what the teacher would do now is just go on, if you can do an online transfer from your Scotiabank account to Excelsior Community College, or if you can go to Paymaster, you're gonna email Students Finance your receipt, and they will update your system. So you don't even have to come to the physical college for that, right? If you choose to come to the college, we welcome you. But I'm just saying to you, if you can not come to the college and just pay for the stuff, come on. Same way pay school fees, the same way do this. And thanks for reminding me about that. And then I will encourage those of you who have not yet paid your fees or make arrangements that you do so soonest, because we don't want anybody to be disenfranchised at all in any way, shape, or form. This is a lovely family and we're going to stick together. Go ahead, Donnie.
so sir, just give them my ID number as it is that I did for the the first time and collect the receipt. It's the same procedure.
Okay. Yes, sorry, the same procedure. That's what you asked. Is it the same procedure?
Yes, sir. I asked.
Yeah, man, it's the same procedure. It's the same procedure. And then now when you pay that amount, okay, so for example, you're paying for foundation English alone outside of, all right, put it this way. Say you finish off your associates, or finishing off the associates, and just have this your one big course left, and you just have to pay for this course. You just go ahead and pay for it. I don't know how much is it for the course. I don't know how many give students amount. So say for example, it is $5 for the course. What you do, you pay the $5, and then you send an email to Students Finance. They respond pretty quickly to say, here's my receipt for $5, and I'm paying for foundation concept in English. And you ask them to update your account, and you check your area to say update, and you can complete your final step on Aaron to complete registration. It's the same procedure. You don't have to worry about it. Same procedure. Let me ask a question though. I'm a little concerned because I'm seeing Elizabeth back with us. Elizabeth, are you using data or Wi-Fi?
Their Wi-Fi.
Okay, great. Is there anybody in the class that is using data? Please say no.
Flow internet is basically data service.
Oh, crap. All right. So, well, I know it may be difficult for you, but all right. So, what I'm going to do. Oh, by the way, Elizabeth, you understand what it is that we have projected here for the answer for this? How I got my 1 on 3 raised to the third power?
Not really.
All right, no problem, and that's fine. So allow me to go through this one again, and then what I'm going to do, I'm going to use today's class to just do as many questions on indices, because that's all we did. Unit 1 is indices, Unit 2 is logarithm. I have circulated a Unit 2 document also. So what I'm going to do is just spend today to just go through some well, as many past people. I sent 4 in the group, Nobody knows the thank you yet, but I sent 4 in the group, and we're going to work as many questions. So by the time we finish working the questions, those who are just joining should be able to see how these questions are answered. And then we're going to recirculate the 2 documents, the one for Unit 1, the one for Unit 2, so we can read ahead of time for next class, because you guys will be the ones who will be ahead of the other students to join. All right, so what I'm saying, this is a question given. The question given was evaluate 9 times 1/3 over 81. Write in your final answer as an index. Now, the mere fact that them said to you write your final answer as an index is an indication that what it is that you're going to be doing is to convert everything into indices. It's an indication that you converted everything into indices. Now, if you don't convert it to indices, you're going to have a problem. You're going to have a problem, because the question says convert to an index. So you have to make sure that you convert it to an index or indices. So what I'm doing, I'm converting 9. 9 can only be converted as an index by writing it as 3 squares. Then, sir, what is an index? What is indices? All right, so you're going to have a base and you have a power. You're having a base and you're having a power. See here? So this is a base, A, and the power or exponent or index is written up top as a superscript. So the superscript is an N, and that's a power or an exponent or an index. And this A here is in the base position as a base. All right? Now, and I said before, I will send you all of those. You don't have to worry about not getting that. You don't need to write it either. So now, what we're going to have is this 9 is converted as 3 squares, all right? And then this 1/3 can be converted as 3 to the minus 1. How, sir? Because when you have 1/a to the positive n, like where you have 1/3 to the positive 1, it can be converted as a to the negative n. So whatsoever is in the denominator, I'll put it to the numerator, and the sign changes from positive to negative. So 1/a to the positive m can be converted as a to the negative m. So that's exactly what I did right here. Because when you're not seeing a power, you're going to assume 1. When you're not seeing a power, you're going to assume 1. Sir, what do you mean by assume 1? All right, thanks for asking. When you're not seeing a power like a, you can assume it is a to the first. So when a number is written like a, anything that is raised to the power 1 remains the same. So a is the same thing as a to the first. If you're not seeing a power up here, it's not 0, because anything raised to the power 0 is 1. So if the power is 0, I have to write it as 0. So anything that is not raised to, you're not seeing a power, you're going to assume 1, always 1. Then so it's going to be 2. If it was 2, then we have to write it. Anything outside of a 1, then have to write it. So if you're not seeing it, you can assume that it's going to be 1. So a is the same thing as a to the first power. All right. Now, having said that, so I'm going to have 3 to the negative 1. And I'm converting 81 as 3 to the 4th, because 3 times 3 is 9, and 9 times another 3 is 27, and 27 times 3 is 81. So it's 3 multiplied by 4 times. So that's why it's 3 to the 4th power. Then when you look at this law, it says, when I'm multiplying and the bases are the same, I add my powers. So a to the m multiplied by a to the n is equal to a to the m plus n. So when I add these m plus n, I'm going to get 3 plus negative 1 is going to be positive 1. And that's how I got this 3 to the first power. Similarly, this 3 to the 4th, I can't break down any further. So I'm now going to have 3 to the first over 3 to the 4th. Now there's a law that says, see here, a to the m over a to the n is going to be equal to a to the m minus n. A to the m minus n. A to the m minus n. All right? So I am subtracting. I'm subtracting. So when I subtract now, I'm going to have 3 raised to the 1 minus 4 is going to be equal to 3 to the negative 3. That's what Tell me if you get that so far, Elizabeth.
Yes, sir.
Good job. Good job. All right. Now, it's time for me to share my document. And this is time now for you to start doing some stuff for me. So I am sharing a document. And this here is my past paper 2012. Past paper 2012. And past paper 2012. And we are going to be doing the questions on indices. All right, so we have not yet touched logarithms, so we're not touching this question yet. But a question here and a one here. So A and B1 is what I want you all to try for me. A and B1 is what I want you to try for me. And these are nice looking type of questions. So based on what it is that I went through a while ago, Elizabeth, is the same thing. Matter of fact, I want you to try this one first. I'm going to see if I can write the question myself, type the question rather myself, and work it on paper so you can see, so we can go through it step by step. So I'm going to give you 5 minutes to try and do this for me now. All right? Thanks.
Sir, also one. B?
B1, yeah.
B1?
Yes, sir. Sorry, you know, so I talk to myself and never recognize I'm muted. I'm going to ask that you refer to the past paper in the WhatsApp group, as I need to use the system to do something else. And I'm projecting some of these laws. Let me project the laws this way, so anybody needs to look back at it. Those who don't have the information that is can easily see what it is. So I'm projecting the laws. All the laws are projected like that for those who just joined. And look at the past paper in the WhatsApp group for the question. All right. All right, guys, how do you feel? All right so far? Hold on. Students, are you okay so far? Have you completed the question?
Yes, sir.
All right, all of you completed or just one person? All right, I'll give you another 3 minutes. Just continue looking at the question. All right, do me a favor. The person who says yes, can you do question 1 for me, please? In that paper, question 1. I want you to do 1 and 1B. So do question 1, please. Students? All right. Oh, my system wasn't responding, so I couldn't go today. To do the question for the one that I just gave you. All right, so continue working. Let me just do the question in the meantime. My system wasn't responding. All right, that's soon come. Somebody calling me?
Someone was calling you?
Yeah. No?
No, I don't think so.
Oh, okay, then all right, cool. I'm actually trying to do the question, but my system freezing up. See, it's not responding again. Be around with me. I don't know what is happening this morning. All right. All right, guys, check to see if that is a correct question because I am seeing a negative 3/4. And only if everybody is seeing the negative 3/4. Check for me, please.
Yes, sir. That is the right question.
All right, cool.
So that's almost you will do it, sir, it wrong.
Yeah, if you use positive 3/4, you're not going to get the full mark.
So I'm gonna be honest with you, I never start and never stop because fraction and you can.
All right, no problem. Thanks for the honesty. All right, I'm doing the question now. All right. Anybody agreeing with what it is that I have so far?
Sir, you can do it with 4, 2. You said 4 to 4 squared, yeah.
Yeah, man. Same difference. Yeah, man. Still can work like that. But your final answer, did you get the same thing like I got?
No, sir.
All right. Hold on. Let me fix it up a little better. Hold on. Let me fix it up a little bit.
Sir, what to do with the negative, the 2, -3?
I put it in the denominator, it becomes 2 to the positive 3.
Repeat, sir?
I put it in the denominator, and it now becomes 2 to the positive 3. You got me?
Yes, sir.
Sir,
Hold on 1 minute, please.
sir, what the tool gone in the third part?
Give me a minute, DeAndre. 1 minute, please.
Giving persons time to write down.
Where they relive yesterday.
All right, sorry. DeAndre, you're asking where what goes, where what went where no?
Two, the two negative cube.
Which two negative two?
Above
Two
the one
negative
on the
three.
blue, where the two go.
The 2 to the negative 3.
Yeah,
This one?
yes, that one.
Right. So, okay. So the 5 to the third times 5 to the 2/3 gives me 5. All right. And this 2 to the negative 3, I put it in the denominator, it becomes 2 to the positive 3. So I'm going to left with 3 to the third in the numerator.
Okay.
You follow that?
Yes.
Good. And then this 5 in the denominator means that it is being multiplied by 1/5. So what I did now is to put the 3 to the third, the 3 to the third, I can pull it out and show you something more. Is going to be equals to 1/5 times 3 to the third over 2 to the third. So that's what it is. So I am grouping those things together. In the denominator, I have a 5. So what I can do is just pull it out as 1/5. If the 5 was in the numerator, I would just multiply it by a whole number 5. But because a whole number 5 is in the denominator, it is really 1/5 that I'm taking out. So we have 1/5, and this is 3 to the third over 2 to the third, and I can group all of those together and call it 3/2 all raised to the third power. So that will be my final answer. Are you okay with that now?
Yes.
All right. Is there anybody who is not seeing that just yet? Talk to me.
Sorry, can you explain it over again?
No problem.
So you can explain it from the beginning.
No problem. No problem. No problem. No problem. No problem. So this is a given question. That's the given question. All right. Now, when you're doing the questions on indices, what we're required to do is to break it up into its lowest term. Break it up into its lowest term. All right. And that's what it is that I'm going to try and do. Breaking it up into my lowest term. And 9 is going to be 3 squares. 9 is going to be 3 squares. 9 is going to be 3 squares. So that's what I did. This 9 is this 3 squares, and I put back the power 3/2. 16 is the same thing as 2 to the 4th. Now somebody was saying, so I use 4 squares. Okay, not bad. But as a hint, sometimes the denominator will give you a hint as to what it's going to be. You see, this is, and I said sometimes, it doesn't work all the times. So you know that this is a 2 here, and we have a 3 squares here, so the 2's will cancel out. And we have a 4 here, so it's a good indicator to say what I can raise to 4. You know, it doesn't always work, but it's a very good indicator. So it's going to be 2 to the 4th, so that you can get rid of the fraction. All right, so this 16 is really 2 to the 4th. If you don't believe me, check it. 2 times 2 is 4, times 2 is 8, and times another 2 is 16. And then the 5 to the 1/3 is in its simplest form, and the 25 is going to be 5 squares, because 5 squares is 25. So what I've done in this line here is to convert my stuff into indices, right? So I'm converting the terms into indices. All right, that's all I'm doing, just converting the terms into indices. Then I'm going to apply the indices here now. So A to the m raised to the nth power is equal to a to the mn. When you have a base raised to a power, which in turn is raised to another power, you're going to be multiplying the two powers. All right? So this 2 is going to multiply by this 3 over 2, and it's going to give me 3. Similarly, this 4 is going to be multiplied by this 3, negative 3. Oh, I'm sorry. No, I'm correct. This 4 is going to be multiplied by this negative 3 over 4, and it's going to give me negative 3. All right? So let me show you what the law says. The law says here, when you have a base raised to an index, which in turn is raised to another index, you multiply both indices. So a to the m raised to the nth power is going to be equal to a to the mn. All right? So whenever you have a base raised to a power, which in turn is raised to another power, we're going to be multiplying both indices. So that's exactly what it is that I'm doing. Multiplying both indices in order to simplify the stuff, which is what I'm saying to you. You will be able to which is why it's important for you to know all the laws of indices. All right, I'm getting back. So now, so when I do that, 4 times negative 3/4, I'm going to end up with negative 3. This 1/3, I can't do anything more to it, so I just write it back. But this 2 can be multiplied by the 1/3 to give me 2/3. All right? And then now, I'm applying the law. When I'm multiplying and the bases are the same, I'm adding my powers. So because the base here is 5 and the base here is 5, I'm adding my 1/3 to my 2/3. And 1/3 plus 2/3 is 1. So which is I have 5 to the first. But this 5 is in the denominator and it's a whole number, can't be written as an index. So I can pull it out. And when I pull it out, I still end up getting the same results. Same results. All right. Now, and if you don't believe me, you can check both answers. You can check this piece here in blue with this piece, and you recognize you get the same answer. All I'm doing here is just simplifying it in its lowest term. So I'm pulling out the 1/5 from here. The 5 is in the denominator, so it's really 1/5. If the 5 was in the numerator, it would be a whole number 5. So once the number is in the denominator, it becomes a fraction. And then I'm going to be left with 3 to the third over 2 to the third power. And then I recognize that the powers are the same. The bases are different. So since the bases are different, I'm going to write back the bases here and just raise it to one single power. And this now becomes my final answer. Let me know how it feels so far. I'm not hearing you guys. You're not talking to me, and I'm not going to go through this semester with you not talking to me. Yeah, man, when you have to talk to me, let me know, say, what I'm doing is understood.
Sir, I understand. I thought at first that since it's raised to a fraction, you had to square root the number, but that's what I thought.
All right, so you see what is happening, otherwise no then.
Yes, sir.
Thanks, Elizabeth. And I'm happy for that. I'm very happy for that, as a matter of fact. Okay, so let us now look at the other one. Let me see if I can. Oh, sorry, I'm in the wrong document. I need to go to the question. And what year is this? This is 2012, August 2012. 25a squared b to the 6, 25a squared b to the 6, 25a squared b to the 6, 25 25a squared, 25a squared b to the 6, and all of that is raised to the negative 1/2, raised to the negative 1/2. Twenty-five a squared b to the 6 raised to the negative 1/2 times 16a to the 4 b to the 8, a to the 4 b to the 8, a to the 4 b to the 8, a to the 4 b to the 8, copy, a to the 4 b to the 8, 16a to the 4 b to the 8, raised to what? 1/2? 1/4? 16a to the 4 b to the 8 raised to the 1/4. All right. Okay, so we have that one. I am going to show you what is happening here. How do I show it now? Let me show you. I always break down into its lowest term. Every time you get a question like this, always break down to its lowest term as an index so you can see exactly what is happening. So that's the first step that I would take. That's the first step that I'll take. 5 squares, a to the second power b to the 6. And I'm breaking it down. Now, you see this negative 1/2? It is going to govern all of these terms in here. And this 1/4 is going to govern all the terms inside here. So look at what I'm saying. That becomes 5 to the negative 1. That becomes a to the negative 1. That becomes that to the negative 3. And that becomes 2 to the first power, to the first power, to the second power. Tell me if you see what is happening here. I'm using the law. Copy. And then I'm using the law. Recall. Oh Lord Jesus, forgive me. Let me see. So a to the m raised to the nth power is equal to a to the mn. A to the m raised to the nth power is equal to a to the mn. So what I'm doing, I'm using this power to multiply each of the powers inside the parentheses. This 1/4 to multiply each of the powers inside the parentheses. Let me show you because I don't want you to times negative 1/2. Copy. Is is copy, paste, copy, paste. Copy, paste. All right, so this is exactly what it is that we're doing. This -1/2 is multiplying each of the terms, each of the powers, not terms, but each of the powers, multiplying each of the powers here. I don't like how them so close to each other. So let me give them some breathing space, social distancing. And as I said before, those of you who are just joining may have a difficulty following fully, and that's why I'm going through all the steps here. And I'm positive that by the time I give you the handout that we used for the last couple of weeks, that you will see the stuff. And besides, I'm going to go through all of this again when the new students join. So you don't have to worry about it. Everything that I've done so far, I'm going to go through again, including these questions. So what I'm saying to you is each of the powers, this -1/2.
This semester won't be pushed back.
Yes, man. It has actually pushed back. Your exams will be held in January instead of December. I thought I said it. Yeah, man. So the semester is pushed back because the start date is now October 25.
Sir, but some teachers are saying that like for their course it won't be pushed back.
No, sir. And that's, well, I was in the meeting.
I don't mean like formally. I mean like they themselves won't push back their course.
Well, it depends. So for example, I am teaching a Calculus 1 course that the bachelor students know. And I have not changed my times. I'm still teaching. I know I will finish the syllabus in December, and then I will give the students their Christmas break, and then I'm going to have about 3 weeks in January, and I'm going to use those 3 weeks for revision with them, you know. But so some lectures will continue. The second, third, and fourth year classes are going on as scheduled. It's also first year classes that are somewhat you know on the being retarded because of the delay in the posting of the CSEC results. And pre-calculus here is a first year course. So that's why, you know, so they're not going to just run some exams in December and then some exams in January. So all the exams are going to run in December, whether or not the teacher finished beforehand, you know, so it gives us an opportunity to complete all our pieces on EducaSoft and have time enough to work past papers. I don't want to, you notice what I'm doing? I could have moved on into logarithms, but I decided not to move on into logarithms. I'm just do some questions. So by the time at the end of the class, those persons joining us now will get a feel as to all one or two of the laws will work out. All right. So let's go. So that's what it is that we're doing here. So let me put this record up here still, because that's where it now belongs. Oh no, not there. Cut. Okay. That's where it belongs. All right. So when we do this now, this 2 times this -1/2 give me -1. 2 times -1/2, -1. 6 times -1/2, -3. 4 times a quarter, 1. A quarter, 1. 4 times 8 times a quarter is going to be 2. All right. Then I can remove my brackets. REMOV, removing the parentheses. EAR, removing the parentheses to give me copy and paste. When I remove my parentheses now, I'm going to get all of these numbers multiplied by each other. All of those numbers multiplied by each other. So in big school, when they don't see the multiplication sign and you see them look like so, it means that they are multiplying. That's exactly what it means. So what I'm going to now do is to anything with negative signs, well, let me group them first. Grouping like terms. Copy, paste. I'm grouping all the A's together and all the B's together and all the whole numbers together. So I get it like that. And then when I'm multiplying and the bases are the same, I'm adding my powers. When I'm multiplying and the bases are the same, I'm adding my powers. So I'm reducing what is happening here. When I'm multiplying and the bases are the same, I'm adding my powers. All right. And then that's where I'm at. And when I move on from there, let me just finish off this here. Copy, paste. I'm going to do -1 plus 1, anything that's going to be 0. And this is going to be the -1. And then you can agree that -1 plus 1 is 0. Then we have a to the 0. But what is a to the 0?
There, 1.
Very good. Very good. Very good. So recall a to the 0 is equals to 1. Or anything raised to the power 0 is equals to 1. So look at what I'm going to do. Copy and look at what I'm going to do. I'm going to convert that now to 1. So times 1. And then what I'm going to do is to bring everything now into its normal terms. So everything that has a negative sign, we're going to go into the denominator. Remember, we don't put our numbers as a negative, we don't leave our answers as a negative power. We always convert those negative powers to positive powers. All right. And that's what we do. Now, this one is a little tricky if I were to be honest with you. So that is going to be my final answer. What I'm going to ask you to do for me, I'm going to ask you to take a couple of minutes, to look at what it is that I have on the screen. You are going to note where it is that you're not seeing, and then we're going to go through this question again. All right, so I'm giving you a couple of minutes. Please, I really want each of you to go through just to make sure that you're seeing. It is a lot that we went through, and these are the type questions that will come on the exam. So look at that again. I want you to go through this question again that I have on the screen, just to make sure that you're understanding what is happening there. And then ask me whatever question that comes to mind that you're not seeing, just ask me those questions, and then we can go through the question another time. And before I give you another one, because there's no more indices question on this paper. So I'll tell you which other paper we're going to look at in the meantime. So just go through this while I look at another paper, another question for you, and then we can take it from there. Are there any questions? All right, if there are no questions, I'm going to ask that you turn to, as I said before, I'm going to send you this document. I'm going to send you this document. Go ahead.
What I was going to say.
Would you have me make a start teach web practice?
Somebody saying something?
I was going to say something to you, but I'm see why it never types.
Okay, all right, no problem. I'm happy that you're seeing. All right. As I said before, and I don't want anybody at all, I don't want anybody to feel discouraged. And I'm speaking particularly to my my new students. Don't feel discouraged. It is, I mean, you're going to see this again. I just don't want to move on to anything else. So that's why I decided to just work some past papers. You don't necessarily need to write. I will post this into the WhatsApp group. Similarly, I will also post my YouTube channel where I upload all the recordings, and you'll get a recording for tonight. Not tonight. What is wrong with me? For today's class. All right.
Sir, what's the channel name itself? Because you sent the link in the group, but the link is not something where you can click on, right? So what is the exact name of the channel? You're not sure about that?
Well, the name of the channel is supposed to be Mark Shand because of my channel. All right, let me look back at it and then repost the link here.
Okay, sir.
Yeah, man, cool. Oh, I think I know what I did. Yeah, I had sent you a forward, so therefore you can't click on the link. That's what you're saying, right?
Well, yeah, I can't click on it.
Right. Okay. Let me send you the actual stuff. I apologize about that. All right. 2009. I want you to look at the. Let me see if I can show you what thing they were looking at. New share. I'm just going to show you the question.
All right, so I just share it to the group. Try to click on it and see if it will work.
Yeah, man. Oh, okay. Oh, yeah, right. Yeah, thanks, Papa. Thanks. Forget that you have it. All right, look at this here now. This is a question we're looking at. 2c, the root of xy times x to the 1/3 times 2y to the 1/4 all over x to the 10th, y to the 9th, all raised to the 112. All raised to the 112. All right, and that's 4 marks. So you have the papers in a WhatsApp group, 2009 question 2C. I am going to do the question now while you're doing it so we can go through that question together. All right, so I won't keep posting it right here. So please, 2009 question 2C. You have it. I just sent it in a group. All right, so I'm changing my screen here, and I'm going to be doing the question just like you. Students, do me a favor now, please. Sorry to disturb your work, Do me a favor though. Look at the denominator power. The x to the 10th, y to the 9th, what is it raised to outside of the parentheses?
Yeah, 1 to 12.
What is it that was? Somebody responded to me just now, please. X to the 10, y to the 9, it's raised to what power? You guys supposed to be doing the question, talk to me now.
Sir, 1 to the 12.
1 over 12?
Yeah.
All right, thank you.
So if you're talking, we're not hearing you.
Hold on 1 minute, please. Hold on 1 minute, please. No, I'm not talking. I'm only doing the question. So I have just completed the question. So I'm now double checking it before I come back to you. So just look at it in the meantime. All right, students, I am going to apologize to you for this question. This question requires quite a bit of mastery of the laws. You see how many steps I have? Because every move I make, I documented it. And I'm going to go through it. This is going to be the last question. And then for the day, and what I'll do is just assign the other questions, the other questions from the other two past papers. So anybody got 2 for their final answer? Okay, that sounds like a no. All right, so let us go step by step. And I really want you to have that conversation with me and interject wherever you are to let me know if you're understanding, please. Very important. All right, so let's go. So this is a given question, very ugly looking type question. All right, now let me just go to the law, copy. And as I said before, it's important for me to go through these stuff because this is how they pitch the questions, RECALL, on the exam paper. So the nth root of a is going to be equal to a to the 1 over n. So when you have the square root, remember the square root is an imaginary 2 that is inside the sleeve of the square root sign. There's an imaginary 2 that is inside the sleeve of the square root sign. So that's why all of this is raised to the 1/2. There is an imaginary 2 here. So that's why everything is raised to the 1/2. See here? This m is an imaginary 2. So that's why everything is going to be raised to the 1/2. So that's the only step that I would have changed in this part of the questions. As I told you, I'm doing it stepwise. So this piece is the only piece that I've changed right here. So moving on from this step now to this step, I am breaking up this xy raised to the 1/2 power as x to the 1/2, y to the 1/2. Remember that each term in the parentheses will be affected by the power. So it's going to be x to the 1/2 times y to the 1/2, which is what I've done right here. Similarly, I am doing the same thing right here with everything inside the parentheses here. This 1/2, the 1/12, sorry, is going to be affecting the 10th power as well as the 9th power. So I'm multiplying here by here. Recall a to the m, this recall. We're having this recall here. A to the m raised to the nth power is going to be equal to a to the mn, a to the mn, all right? So this is going to become now 10 times 112, which is right in here, so 9 times 112, which is right in here, so. And then no, I'm just going to rearrange. Oh, A-R-R. All right, so I'm rearranging here, meaning that I'm putting all the x's together and all the y's together. All the x's together and all the y's together. And you notice this 2 right here, so I move it to the front. The 2 in the back here, so I move it straight to the front. And this is x to the 1/2 times x to the 1/3. See here? X to the 1/2 times x to the 1/3. Y to the 1/2 times y to the 1/4. See here? Y to the 1/2 times y to the 1/4. So I'm just putting all the terms together so that it becomes very easy now for me to see what it is that we're talking about. And the x to the 10th times 1/12 is going to be x to the 10 over 12. And y to the 9 times raised to the 1/12, raised to the 1/12 is going to be 9 to the 9 over 12. All right, and remember the law that says a to the m raised to the nth power is a to the mn. So let me say that one more time. X to the 10th raised to the 1/12 is going to be a to the m raised to the nth is a to the mn. So this term now becomes x to the 10 over 12. See right here, x to the 10 over 12. In a similar fashion, y to the 9 raised to the 1/12, we're using the same law, a to the m raised to the nth power is going to be a to the mn. So that becomes y to the 9 over 12. See here, y to the 9 over 12. And then I am applying the laws of indices, applying the laws, APPLY, the laws. So I'm applying the laws of indices here. So when I'm multiplying, just like this, and the bases are the same, x and x are the same, I'm adding my powers. So that's why I have 1/2 plus 1/3. Y and the y, bases are the same, I'm adding my powers, 1/2 plus 1/4. There's nothing for me to add in the denominator, so I'll leave it alone. And notice what I did, I just take the 2 and just put it in front of this, so that I don't have, it still the same thing. I can't put it in the denominator, it has to be either in the numerator or in the front. And then I am going to now evaluate 1/2 plus 1/3. And 1/2 plus 1/3 is 5/6. I am not here to show you how to add those fractions, so that's going to be your homework. I'm just going to say to you, 1/2 plus 1/3 is 5/6. And I'll also say to you, 1/2 plus 1/4 is going to be equals to 3/4. You need to go and do this. This course is not a foundational course, it's pre-calculus. So I'm expecting you guys to know how to do these fractional calculations. So again, now, so I have reduced my calculations, and then now I'm recognizing that I'm dividing and the bases are the same. So I'm going to subtract the powers. So you know what I did? I just decided to carry everything to the numerator. So I said x to the negative 10 over 12, is it here? X to the negative 10 over 12, y to the negative 9 over 12, y to the negative 9 over 12, and bring everything in the numerator and just forget about the denominator something. It works out to be the same. And again, when the bases are the same, I'm going to be adding the powers. Now, let me just put another line here so that you can see, because I don't want to take anything for granted, and I want you to be able to see what is happening. So that's what is happening. So that now becomes 5/6 minus 10 12. And then it also becomes 3/4 minus 9 12. Now 5/6 minus 10 12 is 0. I'm not here to teach you fractions. You need to go and double check it on your own. Similarly, 3/4 minus 9 12 is going to be 0. And we know that anything raised to the power 0 is equals to 1. So this is going to be 2 times 1 times 1, which is equals to 2. Ask me your questions. We're ending at 11 o'clock this morning because it is that we started about 8:30. So we're actually getting in about 2.5 hours today. So go ahead and ask me your questions. I'm going to send you this document immediately. And what I'll do for those students who joined, you notice I didn't ask anybody to upload, to resend anything in the group, because I wanted to just wait until I would have done today's class with the past papers. And so we did that one question today, and we did some past papers, 1, 2, 3 questions. All right. So I'm going to be sending this in the group, and then also for those of you who are joining, we'll have the additional notes to go through and to look at. All right. So my question to you before we wrap up, are there any questions? How do you feel? Matter of fact, let me ask a question specifically. DeAndre, how you feel? You feel that something that can work? Are you feeling comfortable so far? Talk to me.
Sir.
I'm hearing you, Papa.
Fractions.
The fractions business, they might kill you, right?
You never like fractions since I got school. So it's just like.
Yeah, understood. Understood.
The next part I'm never hear or get at the part where after you have x, the 1/2 plus 1/3, it come down to 5/6. The part there, or it move from the top.
What move from here to here? So, all right, okay, got you. I made us put in another line then. Okay, I got you. Okay, so fractions is what is that is a problem. All right, so let me tell you. So what's going to be the LCM here? If you have 2 and 3, what will be the LCM?
Oh, that's it. Okay.
6. And then 26 was 3 times, so 3 times 1 is 3.
Yeah, if that's it, then it is it. I
Yeah,
understand.
man.
That's not
Yeah,
what I
man.
do.
Yeah, man. That's what we did. All right, Elizabeth. Calling upon all the new
Yes,
people.
sir.
How you feel?
Sir, I basically did it in 11th grade, but I didn't remember most of it, but it's coming back.
It's coming back to you. Very nice. Very nice. I'm happy about that. All right, very nice. And this is your first class, so that's very encouraging. I'm calling it. I don't know if you can speak. How are you? Nah, maybe she can't speak. Donnie, how are you feeling, honey? All right. Georgie, how you feel?
Sir, in the first half, it was confusing. However, I think I need some practice with it.
Okay, and that's fine. And that's fine. I'm happy that you recognize where you need to go. And finally, Christian, how you feeling, Papa?
Yes, sir. I'm okay. Sir.
Very nice. All right, so I'm going to end here. I'm gonna send you this document immediately. What I'm going to be doing is, should I? Yeah, I may just type the other questions from the past paper into the document. I won't necessarily do them now. I'm going to just type the other questions from the document and then send off to you. And I'm going to ask that you can spend some time, preferably before, what I'm going to send you the document immediately. Class supposed to finish at 12. I'm going to send you the document immediately. Then I am going to start working on those questions now to give you another opportunity to just look over. Don't just put on the book just yet. Look over, read over, and try some more questions. Because remember, now I'm still going to go through this topic again. But I want to give you, if I can be confident that you guys can move forward, I will know how to differentiate my class when things are going. But I will see how that works. But as per usual, you did pretty well. Thanks for participating and coming out. Thanks all of you. And we'll link up next week. We can continue our conversation in the WhatsApp group. All right?
Yes.
All right. Later then. Take care.
Sir, please confirm about what the lady said.
Yeah, man, I'll talk to you. Yeah, man, I'll talk to you, Papa. All right, cool. Take care.
So,